I'm here today at the University of Leeds with Professor John Blacker and Professor Nick Kapoor, and they're going to tell you a little bit and introduce you to the fReactors that Asynt are marketing, developed by University of Leeds, on how they work and why they exist. So I'll pass over the microphone to John.
Thanks, Martin. So just a little bit of history to start with. So most people will want to do continuous flow chemistry, think of them being in tubular systems. The disadvantage of most tubular systems is that they're limited to single phases, so often people dilute things down so they can get them into solution so they can pump them through. The other thing is that the residence time within tubular systems is only designed for relatively fast or medium rates of reactions, whereas if you need long residence times, it's often very difficult. So myself and Professor Kapoor came up with the idea of a continuous stirred tank system, which has been known for many years, but always they've been used at large scale without chemists needing to have small amounts of small amounts of starter material. It becomes very difficult for them to use existing continuous stirred tank reactors. So the idea of the fReactors was that the scale would be much smaller, allow multiphasic reactions and allow long residence times as well. So I'll pass over to Professor Kapoor, who's going to explain something about the design of the fReactors.
So thanks, John. So these are the fReactors. So the fReactor Classic, which is the unit that you can see behind me, just pick this off the hot plate, actually consists of 5 of these, and we've designed them that way so that the reaction residence time distribution, that's how long the reactants spend in the reactor, is very tight. It behaves quite like a plug flow type system. This is a single reactor, so it's been through quite a few iterations, as you well know, John, because we've dissolved a few of these and broken a few in the lab, and this is probably about the 4th generation. Now that's actually really convenient to use. So these get plumbed together on this heating block. So we typically would plumb 5 of these together, and each one contains an individual stirrer unit. And if I just take this single unit, I can just show you how quick and easy it is to deal with. So you can just very quickly undo the front bolt, and you can slide the lid off, and that very quickly allows you access to the inside of the reaction chamber. So the idea here is you can do multiphasic reactions, and they'll run for a period of time, and then you might need to take the reactors apart and just clean out the reactant. So it's a very straightforward design, but like I say, there's been a lot of design work that's gone into that, and our chemists have used it for all sorts of things, haven't they, John? So
that's
you can
right,
tell
Nick.
us about those.
Yeah, that's right, Nick. So we've done lots of different multi-phase reactions. So liquid-liquid reactions, one of the simplest example is putting oil and vinegar together to make a vinaigrette. We've done, because of the good mixing, we've done some very fast reactions. We've done gas-liquid reactions, so hydrogenations, for example, with a homogeneous catalyst. We've also done reactions that evolve a gas during the reaction, like CO2, for example. We've done gas-liquid-solid reactions, so, for instance, palladium on carbon catalyst with hydrogen gas with a liquid substrate. With long residence time, so maybe 3 hours on those reactions. We've done crystallizations that form a solid during the reaction, or pumping through a solid into the reactor to actually grow a crystal as it goes through. And then we've done things like biotransformations with enzymes or even whole cell systems. So a really broad, wide range. Now, what we're not doing is promising we'll do everything and it'll work perfectly every single time. But the idea is that it's simple enough to be able to wash and clean out if you need to, because eventually some things will block or things may not perform all the time exactly as you expect. And we've designed them to be very flexible, so depending on what the chemistries are, it's designed to accommodate lots of different types of chemistries.
Thanks, John. We've chosen materials of construction so that they're relatively resistant to most chemicals. So these are PEEK bodies, we've got glass windows in there, we've got different types of seals, and yeah, just really flexible types of systems that we've been able to use.
For heating, particularly heating.
Yeah, absolutely. It comes on a on a heating plate, so we can heat this to 100 degrees C, and we run this at normally up to 7 or 8 bar, £100 per square inch, just using a conventional back pressure regulator. Okay, Martin, I'm going to hand that back to you now.
Thank you. Well, my thanks to Nick and John. I really appreciate you filling us in on the fReactors and how they work in the laboratory, and some of the advantages that people can't really see just by looking at them from an image. We've got lots more information linked through the Asynt website. Lots of information from Nick and John that can help you make decisions on whether these products could be useful for you. But we're trying to base these at a sensible price level that really you can start to play an experiment with flow chemistry. Anyway, thanks for watching, and thank you, gentlemen.
Thank you.